Hey guys, and welcome back to another video. In this video, we will discuss arc length. Alright, so let's get right into it. So let's begin by examining some curve in the xy plane. And let's say it looks something like this. Alright. So let's call this x actually. So let's call this A and this B. Okay, so we basically want the length of this curve on the interval from A to B, right? That's what arc length is we're trying to find the length of this curve from A to B. So the way we can do this is let's begin by examining like a small section of this graph, right? So let's say like we have this small section of the graph. So if we zoom into this graph, then we can approximate it by a line, right? So this segment of the graph is approximately just a line segment. So that means we can just find the length of this using the Pythagorean theorem. So right here, we have a small change in x, right? Because we're assuming this is like a small segment of the graph. So we just have a small, very small change in x, infinitesimally small. So we'll call it dx. And similarly for y, we have an infinitesimally small change in y. So we'll call that dy. So the segment, which I'll call LK, L sub k, is just equal to the square root of dx squared plus dy squared. Right? So now to find the length of the entire curve, you just have to add up all of these LKs, right? So we're just adding up all these LKs as k goes from 1 to n, adding up all these. And so n, what represents is like we have n subdivisions, right? So like, let's say we have some like divisions right here, and like in total, we have n subdivisions, right? So if we make, so for each interval that we have, for each subdivision we have some segment. So if we make the interval smaller, we can make the segment smaller. And if we make the segment smaller, we have a better approximation. So basically, if you want to make the segment smaller, that means you're going to have infinitely many subdivisions. So you want to take the limit of this as n goes to infinity, right? All right. And now this should look familiar because we have the limit, we have an infinite limit of a sum. So this is just asking for an integral, right? So this is just equal to the integral from a to b of LK, which is just integral from a to b of this business, which I'm not going to write down exactly like this. Let's manipulate this expression a little bit. So what I'm going to do is I'm going to factor out a dx squared term. And so we're left with a 1 plus dy dx squared. And then I can take this dx squared outside of the square root to get the square root of 1 plus dy dx squared dx, right? Because I factored the dx outside and the square and the square root cancel, so you have the dx outside. So, and all this is still equal to LK, right? It's still equivalent. So it's just equal to the integral from a to b of this business. And lo and behold, that is exactly the arc length formula. So I'm just going to rewrite it here for you guys. Right, but this is the arc length formula right here. All right, good. So let's practice with some examples. So our first example, example 1, we have a function f of x, and it's equal to 4 square root of 2 over 3 x to the 3 halves minus 1. And let's say we want to find the arc length over the interval from 0 to 1, right? Let's just say. So first thing, let's write down the formula again, right? So it's the integral from a to b of the square root of 1 plus dy dx squared dx, right? So what is dy dx? That's just the first derivative, right? So essentially we have to find the first derivative of f of x. So let's do that. So first derivative of f of x, that's equal to, so we get 2 square root of 2x. Yeah, we get 2 square root of 2x. And now let's just substitute this into this expression and simplify it. So we have 1 plus f prime of x squared, right? So this is equal to 1 plus 2 root 2x quantity squared. So here we have 2 squared is 4, and then square cancels. So we have 4 times 2x, which is 8x. So we just have the square root of 1 plus 8x. And this is what we're going to integrate, right? So we're integrating, from a to b, so that's from 0 to 1. And we're integrating the square root of 1 plus 8x, right? So let's see, we can rewrite this as 1 plus 8x to the 1/2 power, right? And then you can just use the power rule. So we add 1 to the power, so we have 1 plus 8x to the 3/2, and then divide by the power. So divide by 3/2 is the same thing as multiplying by 2/3, and then divide by the derivative of the inside, so then times 1/8. And then we're evaluating this from 0 to 1. Sorry about that. But this becomes 1 over 12, and let's see, substitute in 1, and then minus, when you substitute in 0, so 1 plus 8 times 0 to the 3/2, right? So here we get 9 to the 3/2, 27, so you get 27 over 12, minus, this is just 1 over 12. So in the end, you get 26 over 12, which simplifies to 13 out of 6. Alright, so basically, the length of the curve from 0 to 1 of f of x is 13 out of 6. How neat. Alright, let's do one more example. Example 2. So let's say we have some function g of x, it's equal to x cubed over 12 plus 1 over x. And let's say we want to find the arc length over the interval from 1 to 4. Right. So again, let's write down the formula. So it's this integral from a to b of the square root of 1 plus dy dx squared dx, right? So again, we have to find the first derivative of g of x. So let's see, g prime of x equals, you get x squared out of 4 minus 1 over x squared, right? And again, we'll just substitute this into this expression and simplify. So 1 plus x squared over 4 minus 1 over x squared, and see, this is equal to, we have x to the 4th over 16 minus 1/2 plus 1 over x to the 4th. So this becomes x to the 4th over 16. The 1 minus 1/2, that becomes plus 1/2. And then we have plus 1 over x to the 4th. Okay, and notice that we can factor this as simply just x squared over 4 plus 1 over x squared squared, and then the square root and the square cancels, so we're just integrating this inside expression. So we're integrating from 1 to 4, right? And we're integrating this inside expression right here, the x squared over 4 plus 1 over x squared. Alright, so let's see. So here we can just do power rule, and then again just power rule, and then we're evaluating it from 1 to 4. So you get 4 cubed over 12 minus 1 over 4 minus 1 cubed out of 12 minus 1. Minus 1. Alright. So this is equal to 4 cubed over 12, so that's 64 out of 12, minus 3 out of 12, so that's 61 out of 12. And then we have 1 out of 12 minus 12 out of 12, so that's negative 11 out of 12. But the negative cancels, so it becomes plus 11 out of 12. So you get 72 over 12, which is just 6. So the arc length of g of x from the interval 1 to 4 is just 6. All right. So yeah, that's pretty much it. So basically the core concept here is like you're just taking a small segment of the curve and you're approximating the length of that using Pythagorean theorem. And then you're just adding up a bunch of those infinitesimally small segments and you end up with this formula. But yeah, if you found this video helpful, don't forget to subscribe so that you don't miss any upcoming videos, and make sure to hit the like button. Other than that, I'll see you guys in the next video.